Hello everyone. I would like to start by sharing one of my biggest frustrations with you. Because when I start to review a pull request, I usually have some comments like some simple code style issues or some subtle bugs that I find. And well, I write a comment about that. This in itself is of course not really a problem. But this gets frustrating when it's the fourth time that week that I'm putting a comment about the same thing on a pull request. Because I start to wonder, I don't want to have these repetitive comments that I need to place. We should not do this manually, we should automate this. Well, today I'm going to show you a solution to this problem. My name is Ossendrijver and I work at a company called Picnic in the Netherlands. It's an online supermarket, but yeah, there we have a good solution such that we can say goodbye to bugs with and anti-patterns with error prone. So error prone is the tool that we're going to use to solve these problems of these repetitive comments. Let's quickly go over the agenda of today. So first I'm going to introduce you a bit more into the code quality issues and the repetitive discussions that we want to prevent. Then I'm going to introduce you to error prone. Next up is how you can start using error prone in practice, because I do not only want to tell you about error prone and what it is, but I also want you to be able to walk away knowing how you can start using this solution within your company and how you can start introducing it. So I'll tell a bit more about how we use error prone within Picnic and some of the lessons that we learned during the use of error prone. And I'm going to show you how we applied a lot of these rules within Picnic. So a big thing that we would like to prevent is bike shedding. Well, what is the bike shed effect? It is about the fact that we waste a lot of time discussing trivial things while we should actually focus on things that are a lot more important. So there's this example where there's a plan to build a nuclear plant, and because there are not a lot of experts about how to build the actual nuclear plant itself, there's going only like 2.5 minutes of discussions about something that cost over $28 million. While on the other hand, there are a lot of experts who have an opinion about the bike shed that is being built for only 1,000 dollars. And there's a lot of discussion happening here. Well, how does this relate to code? Well, let me show you an example. Let's say a colleague of you created a pull request and wrote a comment on this, saying, "Hey, we should use we should use the equals check instead of the .isEmpty operator." Well, who cares? They are like doing the exact same thing. This is mostly a stylistic issue. But what you see is that there are 3 upvotes on this comment, which means that this can easily trigger a new discussion in the pull request saying, no, this one is better than the other. This is the perfect example of something we should automate and where we should not have a discussion about, because it doesn't matter. Well, it's okay to have this discussion once about which one is the best and which one you prefer for reasons, but then as a result of that, you should settle on this decision as a company, and then you should make sure that this is enforced across the whole code base, and that you automatically migrate all the other occurrences to the one that you prefer. Of course, this is a very simple, silly example, but you can apply this to many, many things out there. Again, to make sure that the repetitive discussions about these things are minimized. Because let's say you have a team where you had a lot of these discussions, you have a lot of this code style within that you agreed upon within the team, but if you switch to another team, you will have all these discussions again. And if you solve this problem company-wide, then you will not have this problem. Some other simple examples of what you can encounter on GitHub. Please use immutable list instead of collection.emptylist. Same story holds, both do exactly, well, almost exactly the same. But yeah, the idea is the same. Another one is, hey, test methods should not be public. True, but yeah, something good to automate instead of having to put a comment on there, checking the pull request out again, applying the change, seeing if the change is applied correctly, and so on and so forth. And the final example is make sure to add the final keyword, something we should also automate. So within Picnic, we use quite some tools that help us, help the developers with some quality gates and point out these things that are different, that should be improved, basically. All these tools are then focused on minimizing these discussions. A very good example and a very simple example is the use of a strict formatter. So internally we use the Google Java format, which is a fairly opinionated formatter, so there are no discussions possible about where to put the curly bracket, either on the same line as the class definition or on the next line. This already saved years of development hours within Picnic. Another type of tools are the static analysis tools. So for example, Sonar Cloud, Checkstyle and Spot bugs. These tools can detect these bugs in your code. They will point them out, fill the build for you and say, hey, please fix this before you are going to merge this. So they are the industry proven best practices, but they still only flag issues for you. And that is actually not enough. We would like to go one step further than only flagging issues. So that brings us to the next part, which is my favorite part, because here I get to say, allow me to introduce you to ErrorProne. ErrorProne is an open source static analysis tool created by Java, and it can not only detect and flag bugs and issues in your code base, it can also automatically fix these violations for you. So how does that work? Well, ErrorProne is a compiler plugin, so it runs during the compilation of your product, your application. That's the word I was looking for. So how does it work? Well, let's say you have a simple Java class and the compiler starts compiling that class. It starts to gather a lot of extra context about your Java class. It does type checking, naming resolutions, all kinds of additional checking whether your program is correct, and gathers a lot of extra data. So we have the class, then the compilation is done, and right after the compilation is done, ErrorProne kicks in and can use this additional analysis from the compiler to do a much more thorough analysis of your code base, while still having a link to the actual source code. So it knows which new lines you have, which spaces you have used. So what it can do, it says, hey, I found an issue, I know how your code looks like, so I can provide a suggested fix for you. And then if you run ErrorProne in patch mode, it will not only suggest the fix, it will also automatically fix it for you in your source file, which means you don't need to do anything, you just run ErrorProne and your bug will automatically be fixed. This is even more interesting if you have a large code base and you start enabling one specific bug pattern. That is how an ErrorProne check is called. So let's say you enable a bug pattern, it will find all the violations throughout your code base. And if you run it then in patch mode, it means that all these violations are automatically fixed by ErrorProne. That is quite powerful. Also good to note that there are over 500 ErrorProne checks provided out of the box. And there are like 3 different severities. You have suggestions, you have warnings, and you have errors. And you can also tweak that just how you want it to be. There's one downside, however, to writing ErrorProne checks yourself. That is that it is quite complex to write this. For those of you who know, you have to work with the abstract syntax tree of your code. And that can get complex rather quickly. So what they did at Google, they wanted to make it a lot easier for developers to specify refactoring operations, to simply improve your code. Well, they created a tool on top of ErrorProne, and that tool is called Refaster. Refaster is a tool with which you can specify these refactorings using before and after templates. So in the before template, you specify what code you would like to match in your code base. And then in the after template, you specify to what it should be rewritten. Let me show you an example. So at the top, we have 2 methods, and at the top we have the before template. You see that through the annotation. What is important is the method body here. The parameter and the method body. So the idea is that when Refaster is analyzing your code, it will go over all the different string expressions in your code base and put them right in here. Let me get my laser pointer. All the different string expressions will be put in here as a string. And then Refaster will check, hey, on this string expression, are we using the equals operator? Just like this example. So we see some random string field, it will be put in there as a parameter, and indeed we use the equals operator. And then we say, okay, we have a match in the before template. Then we would like to rewrite that to the content that is provided in the after template. In this case, the .isEmpty operator. So then, if we apply this on this example, then we get this simple transformation. So again, this is a fairly simple example, but you can imagine that with this, it is really easy to specify something, which allows all developers to specify these kind of simple operations and makes it a lot easier for them to do so. There is one downside to refaster, however, and that is that this refaster only runs on expressions and statements. So you can generally only change things inside method bodies. So I'm going to show you a demo because it sounds nice, but I also want to show it to you in action. But before we go to IntelliJ, I want to explain you two Maven profiles that we're going to use throughout the presentation. So we're going to see a normal Maven build. And by the way, I need to say that it does not only work with Maven, but also other build systems like Gradle, Bazel, and so on. So we're going to use a Maven build, and on top of that, we're going to add extra configuration. So when we, so there are two profiles, and the first profile is the error-prone profile. So again, we have our normal Maven build, and if we pass the -p error-prone flag, which we'll see in a second, then this additional configuration is added on top of our build. And what we see here is that, we hook into the compiler by saying, hey, we want to use the Maven compiler plugin, and with this parameter we say, okay, we enable error-prone. And then we can configure error-prone just like how we want it. This is a simple example where we say, hey, the Java 8 API checker, we would like to disable that. And here we can also say that, for example, errors should be warnings or the other way around. And we can have a big list of checks that we want to configure. And another profile that we are going to use is the patch profile. So first we say, okay, our build, add error-prone, and the next one is run error-prone in patch mode. And how do we configure it? Well, we can say, here we can specify which checks we want to run. So maybe even only one check, or you want to run all checks on our code base. And then a very important part is the patch location. So instead of only doing the analysis and saying, hey, here are some problems, we can say, hey, please create, please use patch location in place, which means that if you find a problem, update the actual source file so I don't need to do that. Another option would be to create a patch file, like a git patch file, and then you can inspect that and apply the git patch file yourself. So now on to the demo. No, other one. And for this, I need your input, because we have a very simple class that I created, for demo purposes, of course. And in each of these methods, there is something that can actually be improved. And I'm curious if you can see if something is either wrong or should be changed in either of the methods. There are no wrong answers. You can shoot. Any suggestions? Which ones? 16 and 17 can be merged into one line. Well, indeed, we're creating a copy of an immutable set that was already there. Very good one. We don't need that. Other suggestions? Otherwise, we're going to ask error-prone to take a look. Okay, let's do that. So, as you can see in the bottom, I already wrote something down. We're going to do a Maven clean install. And on top of that, we're going to add the -p error-prone profile to enable the profile. And then we get this extra configuration. So if we run that, we're going to see what it does. Build success. And here we see that error-prone found some things. So for example, on line 21, which is this one, it says, hey, there's a refaster rule that had a match. Did you mean return string.isEmpty? Another one is the line 10, where we have new illegal argument exception. And what it says is, hey, this is the dead exception. Exception created but not thrown. Indeed, did you mean throw new illegal argument exception? because we are creating it but not throwing it. So this is doing something we don't want it to do. And the nice thing is that it not only gives the suggested fix that I talked about, but it also gives a link to the documentation that you can click to get some extra information on this check. And the other one is indeed, as you pointed out, sir, is that there is an identity conversion happening here. So we have the copy of this method invocation appears redundant. Did you mean return set? Well, indeed, we meant to do that. So yeah, of course, we're not going to fix this manually. We can simply use the other profile -p patch to say, please do exactly the same, but instead of only showing the warnings, apply the fix for me. So if I now click here, then indeed we see that it is updated, and we have now the throw new illegal argument exception. We do return set, and we have the string dot is empty. Okay, that is nice. What if there would be one simple edge case where I don't want it to be rewritten by error prone? So for example, this one, I don't want to rewrite that one. Well, there is a suppress warning mechanism that we can simply use for that. And we can say, hey, please suppress this warning. We don't want to rewrite that. But of course, there are also more checks that we can run. So please take a close look at the if statement. And, well, I just scrolled a bit too far. Yes. So the if statement is now replaced because we were literally doing a check argument exception, a legal argument exception. And we just had the return set here, which we can also, of course, directly return here. So that's another check that we can run. And the idea is that sometimes we need to run it multiple times, and that's how we configured it, that it runs till there are no, we run error prone till there are no further changes. Because if you rewrite something, it can like, how to say that, unlock a new, a different type of rewrite. So these were some simple examples, but it should give you an idea of how error prone can work on your code base. So now I will mention a few other examples to give you an idea of what kind of bug patterns are out there. There's a documentation website of error prone itself that you can use to read upon, and yeah, there's a lot of extra information about them. So a specific example is the incomparable bug pattern that says, hey, for every all the types that are in a sorted collection should implement the comparable interface. Otherwise, the sorted collection doesn't make any sense. There's a question in the back. Yes, do you distribute the rule set to multiple distinct build pipelines or products? Can you repeat the question? How do you distribute the rule set to multiple products or build pipelines? How do we distribute the rule set across multiple repositories, basically? Yeah. Okay, we will get to that. So I will save that one for later. Okay. Another one is the immutable bug pattern. So there's the immutable annotation that you can say, hey, this type is immutable. But if you're not really using the type like that, then error prone will say, hey, you said this is immutable. Please make sure that it stays like that and that you're not actually changing fields of this type. Another one is the constant field, where if you have a field that is named with a constant case, then it should be both static and final to make sure it is consistent and clear across your code base. So another simple one is a refaster rule that I wanted to show, because well, at some point the optional .get got introduced, but the release after that they said, this was actually a mistake. We would like it to be a bit clearer, and they also introduced the or else throw. And the Java doc of the optional .get states, hey, don't use the optional .get. Please use the or else throw. Well, because the optionals were already heavily used in every company and in all code bases, there were a lot of optional .get usages, and you would never want to manually migrate all of them because it's quite prone to errors, and yeah, it's easy to miss one. And you, for a long time, you are in this state that you want to migrate to the or else throw, but you're not actually doing it everywhere. Well, with one simple refaster rule, what you can do is, yeah, you can run this refaster rule on your code base, and you will make sure that the optional .get never occurs in your code base again. Very simple one, but really powerful. So that's it about the introduction. Now I'm going to show you how you can start using error prone in your code base, because it can be quite a tricky process. Because as I mentioned, there are over 500 rules provided by Google out of the box. And if you would simply say, hey, I am creating a pool, I'm creating a branch, I will enable all the checks, I will run them, there will be thousands of lines of code changed, and if you would create a pull request, no one would dare to touch it, let alone think about deploying this change and making sure that everything is like correct as it was before. Well, because of that reason, we have to be a bit smart about how we start introducing this. So I created a beautiful roadmap to guide you a bit through it, and I will also show you an example. So we have to take small steps in order to get this tool introduced. So a smart way of doing this is that we can start with, well, introducing the dependency on error prone, making sure it can run, but make sure to disable all the checks that are there. So then it is easy for us to run one specific check on the whole code base. And then if we pick a check that will have a very good impact, we'll find some nice bugs in our code. And if we run that, we can open a pull request and ask our team members for feedback, saying, hey, I tried this first bug pattern, what do you think of it? And they will be like, hey, that found some nice problems that I didn't know existed, and now it fixed all of them in one go. Well, that sounds like a good idea, approves the PR, and then you have your first bug pattern in. But then you need to have multiple of these cycles where you get your colleagues enthusiastic about the changes that you are introducing. They continuously need to think, hey, this is indeed a good improvement. It's very easy to review all the changes because all the changes are really similar in because you enable every time you enable one specific bug pattern. And in a second we will see it is then relatively easy to review them. So they need to get used to these automated improvements, and you need to get them on board, because if you're trying to push something, they will say, and you will push too hard without getting them enthusiastic about it, they will say, no, I'm not reviewing this anymore, and we will not start using this. So you need to be a bit smart about this. So if you repeated this for quite a few times, then you can at some point reach the point where you have all the error checks, so the category error, you will have all of them enabled, and that's a really good first milestone. So it sounds nice, but how do I go about this? Well, luckily I have a demo prepared for that, because I went on GitHub and I went through the open source repositories, and I found quite a big one, which was really in need of some error prone. Because the quality was, I wasn't really glad to see it. Because, for example, there were like over 500 unused imports throughout the project, where I'm like, if you use a simple formatter, then this will automatically be fixed for you. But well, I checked out the repository, I applied the formatting, and then I wanted to actually apply a specific bug pattern to see how it looks like. And that is exactly what I'm going to show you. So here, this is what you saw in the beginning as well. The patch profile. I introduced both profiles, and then we're going to apply our first change to this repository. So what I did is the Maven package, and then -p error prone to enable the first profile, -p patch, and then from the patch from this part I am using the part where I can specify which check I want to use. So, and of course I went through the code base and I saw that there were a lot of unnecessary finals there, which was there, which is unnecessary, so I would like to see it removed. And for that reason I ran this simple check. Well, if I would press enter now and we would wait, it would take quite a long time because it's a fairly big code base. So I also got something prepared for that. If I type this, then we are applying, indeed, the patch unnecessary final. So I just ran this before, stashed it, and now I applied it. And now I want to, of course, push this such that we can inspect it. It's not there. Oh, it's still busy. Okay. So what you can see now, if I zoom in a bit, probably readable. Okay, I see some nodding faces. So what I want you to see is that because we applied one specific bug pattern, if we scroll through the code, it's actually fairly simple to review. even if it's like 1,000 lines of code, after you checked out a few of them, you see, well, this is really consistent. It's just really, all of them are correct. And then you can scroll a bit faster through them, and you can say, okay, I trust this, this looks good, you can approve it, and you can merge it. Instead of having many different of these checks, it will be way harder to review. And because if you approach it like this, people will get into the habit and they will love that you are opening these kind of pull requests. That's kind of the idea of how you can approach this. Still, there are like, because this is a fairly big code base, there are like 4,000 lines of code changed. Well, that's still a bit much, so I will maybe split it. But apart from that, yeah, the PR is created and ready to be reviewed. We're already there. So once again, to repeat, what we just saw is that first I enabled the 2 different profiles. I added the 2 different profiles to the project, and then I showed you how to go from level 1 to level 2 and how to do this repetitive part. So now about how we use error-prone within Picnic. Because we started using this tool for already many years ago, and at some point we were such a big fans of this tool that we actually used almost all, like except for 10, we are using all the different bug patterns on our code base, and I mean on all the different repositories that we have. But still, we wanted to do even more. We wanted to go one step further. So first, a bit about the question that you had above. How do you make sure that it is actually applied on all the different code bases? Well, we have an interesting setup there. So we have about 70 plus different repositories, but all these repositories are using the same, like only one parent, the Picnic parent. And in this parent, we have a lot of configuration and a lot of shared libraries that we define, such that all the different repositories can simply use that without having to implement the same things for metrics, logging, exception handling, all these different things. And the same holds for the configuration of static analysis tools. So for example, we also specify which error-prone checks we would like to run. So if we do a change there, this will automatically be rolled out once a month to all the different repositories, and they get all this configuration for free. So we only define it in one place, and we ensure that it is run across all our Java code. And what we also provide is a simple script, the patch script, which will use both of the profiles to actually, you can run the patch script, and then it will make sure that it runs all the error-prone checks on your specific code base, because the workflow is like this. Let's say, oh, I have a timer. Excuse me. Sorry. So, one step back. The patch script, yes. The workflow is as follows. You wrote some code, you implemented a new feature, you want to actually create a pull request and let it be reviewed. But remember, we wanted to remove all the repetitive, simple discussions by automating a lot of these simple things. So what happens is that our CI will use the following argument to say, hey, if there is a warning by any of the static analysis tools, please consider it an error and fail the build. There are a lot more, but these are the most important ones. And then if the CI detects a warning, that is, then the build will simply fail and say, hey, you cannot merge this. Please make sure to fix all violations before it should be reviewed and either merged. So what a developer can do is check out the code again, run the patch script, and see what changes are being introduced by, for example, error-prone. And it's important that we do not do this in an automated fashion, like, hey, there's a violation, just run the patch script, add the commit, and push it. Because if we would do that, the developer would lose control. And we think it's really important that the developer stays in control, checks out what is being changed for me by these static analysis tools. Do I agree? Should I change something or improve something? And then you can, and then if the developer run the patch script, then you can commit the changes. So, as I mentioned, at some point we used all the bug patterns, but we wanted to do even more. And that is sad because Google itself doesn't provide any refaster rules. It's really nice that they provide the refaster engine that allows you to do this. But we were like, hey, we want to do more. How can we do this? Well, there's this issue from 2017 about the question, hey, can you open source some of your refaster rules? And every year there's a new ping saying, hey, can you already open source them? But up until this day, nothing has changed and they have not open sourced any of them. That's when we decided to start our own repository called error-prone support. And in that repository, we started creating a lot of extra rules. And we had, at some point, we had over 900 refaster rules and about 40 error-prone bug checks. And we went quite a lot further here. We said, okay, we want to make a lot more things consistent, migrate away from old things. We wanted to help out with migrations from JUnit assertions to assert J, or anything goes. And it's really a picnic opinionated set of rules. And apart from, I'm going to show you two examples, some simple examples. So for example, we have the is null refaster rule, where we have, in essence, 3 different ways of checking whether something is null. And we say, hey, please match the first 2 that are in the before template and rewrite them to the content that is provided in the after template. So the idea is that instead of having 3 ways, we have only 1 way in our code base and we automatically rewrite it for you. But we also try to guide you with how to use specific APIs of libraries. In this case, there is one for the SLF4J log statement where we say at the top, hey, instead of using a %s, you should use the curly brackets, and we also automatically apply that for you. And we also detect incorrect usages of APIs. So here we have a format string with 1 placeholder, but at the bottom here we have the log.debug where we are not putting anything in the placeholder, which is incorrect, so we flag that for you. On top of all the rules that we have, we also provide some modules that makes it a lot easier to use error-prone and refaster on your code base. So for example, it's a lot easier to run a lot of refaster rules on many different files in one go. There was also not really test support from error-prone itself, so we introduced that. And during the demo, we saw that there was reporting for refaster rules in the terminal. That is also something that is not provided by Google out of the box. And last but not least, there is a documentation website that I'm going to show you that has, so if there is a violation found, it links to the documentation, and for our own rules, it also links to our own documentation. So for example, we have the direct return check, where it shows you some examples, explanation of why you should directly return. But we also have a lot of things for JUnit, where we say, hey, you don't need to use any modifiers here. Public, protected can all be removed. For example, the test prefix is also not necessary, more like a relic from testng. And there are many more of these checks. A fairly opinionated one is maybe the static import one, where we have a big list of things that we think you should or should not statically import. So instead of using the 2 immutable set, we say, hey, please statically import this one. And we have many more of these. It can go quite far, and it is really opinionated, but it helps our code base get a lot more consistent. And as a result, we can go a lot faster. There's the same for refaster rules. And just to drive the point home about how much we like consistency, I show you this one, where there are 10 ways of checking whether something is empty or not. And instead of having 10 ways, we say, please only use the .isEmpty operator to make sure it is really consistent. So, now briefly about how we started applying all those rules within Picnic, because at some point we had all these rules, but we didn't apply them all on our Picnic code base yet. Well, and we've about 3 million lines of Java code, so this was quite a task to get right. And again, we didn't want to just apply all of them, because our engineers would be like, hey, don't push this, don't determine how I have to write my code, they also want to have a say in this. So we needed to first of all verify if all the rules that we had were correct, if people liked them, were we being too strict, all these things. So we had a very slow approach where we said, a gentle approach is maybe the better word, where we opened pull requests in all the different repositories saying, hey, we applied these rules, What do you think of it? Can you give us some feedback? Do you like it? All of these things, really in an open way, such that they could also be part of this, give their feedback. But what you saw often is that they were pretty open to all these kind of things because we could finally automate these things for them. They would never have to have these discussions about them. And that's what they really liked. So in total, we created over 60 pull requests spread across 40 different Java repositories. And here are some numbers of the pull requests that I created. Based on this, you can guess that my GitHub stats were boosted quite a bit by this. But yeah, still, if you would open a pull request, how would that look like? Well, we split it basically per topic, saying, hey, the first is the comparator refaster rules, the second one, the collection refaster rules. So not split per refaster rule, but we made it per topic, so it was still relatively easy for them to review per commit then. So, of course, there were some good opinions, some strong opinions of people saying, I'm not sure if this is a good thing, and with some elaborate answers on why it was really the bad thing to do. Well, if there was more than once across a few different repositories, we would say, okay, there's something going on here, we should be gentle about this one. And what we did is we said, okay, let's see what everyone thinks. And we created simply a Slack poll for this, saying, hey, yeah, we have this thing that we can choose. There are here 3 ways of writing one and the same thing. Which one do you prefer? Do you prefer something or not really? Let's pick one of them, make it consistent across our code base. And what you usually saw is that some people had strong opinions, that's still fine, but there was a vote, and whereas most people would say, well, as long as it is enforced, I don't really care which one it will be. A nice way of solving this. And still, they were really part of the decision process, so they were a lot more open to this. It helped really well. So finally, about the current state of error-prone support. The idea was that people during the code review were saying, hey, we're now having a discussion about this. And well, let me rephrase that. If people were doing that, we're saying, hey, now this is the 4th time we have this discussion. We had to make them enthusiastic to actually create a pull request in error-prone support. And as a result, we would apply the refaster rule on Picnic on all Picnic Java code, and they would never have to think about it again. But to get developers enthusiastic to come with their own ideas as contributions, we still had to do something. So we used a very powerful mechanism to actually get them to come with their ideas. And for that reason, we created all these custom stickers. And we said, hey, if you make a contribution, you get a sticker. It sounds a bit silly, but for most developers, it works quite well. Oh, and by the way, I have some of them at the end here as well. Yeah, as for the adoption, it's going quite well externally because Checkstyle, which I already mentioned, is also using our rules, and there are some other open source repositories. And well, after we open sourced the refaster rules, another company called Modern, which is the company behind Open Rewrite, was also interested in these refaster rules, and they basically built an integration between the refaster rules and their platform. So between their tool and platform. So yeah, they basically said, hey, we also want to be able to run these refaster rules to increase the coverage that we have with our recipes. And after this talk, Tim de Beek will also give a talk about Open Rewrite in this room. So if you're interested about this, you should stay seated. So there's a small conclusion, but if I skip this one, I can still show you how to create a refaster rule, because I would like to do a last live demo on stage. So I'm going to show you how easy it is to create a refaster rule yourself. And in this case, let me fix this. Yes, what I want to show you is how we go from a string that uses copy value, the copy value of method, where we pass a car array, to new string. And so how you do this is that we have to create the refaster rule, but of course we also want to test this. So we have a testing framework where you have an input and an output. And the idea is that you have in the input, you write the code that you want to match, and the output you specify how it looks like if you get the input, apply the refaster rule, and what then the result is, that should match the output file. So it will be quick, but I'm going to show you this. We have a static final class new string. And we need a before and an after template. The before template looks like this, where we say we are going to return a string. The name here is not really important, and we want to do this not for string, but for every car array. Yes, return copy value of, and then of this one. This is the code that we would like to match. And in the after template, we have to do the same. Return new string. Usually I would talk a bit more, but now I'm on a strict time schedule, so I have to type a bit faster. So this should be the refast rule, but now we still have to write the input and the output. And I have the string rules test input at the bottom, and we are going to return a string, and then we have the string new, let me check, new string r. This should be the test prefix with this, where we are going to return string dot copy value of, and let's write some like this. So this is some code that we would like to match. And if we would now run the test, then we would see that, well, we didn't put anything in the output file. So the output file will now look a bit different. And indeed it says, hey, I found this, which you didn't specify. And it already rewrote it correctly. So that is nice. Because if we go like this, we copy this, and we go to string rules test output. And if I would copy it here without changing it to the new, instead, so we're rewriting from copy value of to new string, but I didn't do that in the output template here. So you see, hey, I didn't find the new string one, which means the refast rule is correct. So I only found the old one. So we say, okay, we want to rewrite it to the new string. And if we now run the test, we see that it is valid. So it took me 4 minutes to write a refast rule. That's quite quick. So if you want to know more about Picnic, you can read up in our blog, blog.picnic.nl. If you're interested in working at Picnic, you can go to join.picnic.app. And with that, we've come to the last slide, where bottom right there is the Slido link that you can use to post questions. Top right is a QR code to the open source repository that I talked about, and some interesting links. And a special mention to Stefan Schroevers, who is responsible for creating error-prone support and also does a lot of work on error-prone support. And with that, I would like to thank you all for your attention. Well, I get the Slido link. Let me check if there are questions. Yes. There was a question out loud. That's also fine. What is this room again? This is room 5. Did you ever experience any bug introduced into the code by a faulty refast rule that did not just refactor, but passed the PR review? Depends on, a bug. Well, I didn't get any feedback specifically about this, but well, if it introduced something that is like non-compilable code, then it will be flagged, of course, because we do like a full install, like a full analysis again once we applied a refast rule. Yeah, based on our size and how many refast rules we have, I think there's definitely a case, but I don't know any specific ones, to be honest. In your example, error-prone rules were applied subsequently to others, but over multiple builds, indeed. Is there a solution to apply all of them at once? Well, all of them are applied and are checking if they can rewrite something, but yeah, we need another compilation round to see if then there are new rules unlocked. So yeah, we have to run them in a loop, because yeah, it needs the new compilation basically to see, are there new opportunities for me to refactor? So all of them run, but we cannot do it in one go. Can you compare error-prone to SonarQube lint? Yeah, of course. The idea of SonarQube is mostly that it flags things for you, but still you need to manually fix them yourself, whereas error-prone can do it for you. I would say that's the biggest one. What do you think is the most important difference with Open Rewrite? Well, I see the guy from Open Rewrite already right there, so he's ready to answer the rest of the questions there after this session. The most important difference is that error-prone really runs as part of your build, whereas Open Rewrite is more for one-off things, and you can run maybe on like a schedule every 2-3 weeks, because it takes a lot more time to run Open Rewrite. So I would say that's the most important thing. And the other thing is that error-prone is mostly focused on single compilation units, which means single source files, whereas Open Rewrite creates a very large tree of your code and can do more easily do bigger rewrites, Spring Boot 2 to 3 migrations or other frameworks. Yeah, I think those were the most important ones. We also did a workshop together a few days ago, so I had that ready. Do you use error-prone for enforcing architectural choices as well? Good question. I would say there are some things that we do. Now I need to, of course, come up with an example. Enforcing architectural choices. I would say we more often use ArcUnit for this. That's the more easiest way. I would say for bigger architectural things, I would have to say no. Because it does this single compilation unit analysis, it's really hard to enforce things across multiple, for architectural things, more across certain things, so not really. I think those were the questions. Not sure if the, yeah. Any other questions like this? No? Okay. Oh, yes. Or not. Oh, it was waving. Okay. Okay, then I want to thank you again for all the questions.